talking about recently in math? And when I say recently, I mean as of yesterday and Monday. Elizabeth? Prime and composite numbers, right? Okay, what's a prime number? Let's everybody say it. Remember what we did our definitions? Let's do that together. So everybody put your hands down. Okay. So let's do it together saying a prime number is a whole number greater than 1 with exactly 2 factors, right? So what's an example of a prime number? What's an example of a prime number, Ashlyn? 5. Why is 5 a prime number, Micah?
Because you can only multiply it 1 and 5.
1 and 5, okay. She says you can only multiply it by 1 and 5. So what is 1 and 5 in relation to that 5? What is it called? What is that one word that when we think of those two numbers or any numbers that are multiplied together to get that number? What are we talking about? Okay, if it's 5 and 1 and 5, what are they to 5? Okay,
Factors.
Factors, right? Okay, so let's think about it. We know that prime numbers are ones that have exactly 1 in itself, right? So in a T-chart, we could go ahead and say that 1 and 5 are its factors, right? But isn't that the same as saying 1 times 5, right? Which equals what? 5. So 1 and 5 in a multiplication problem are, what did we say? Factors. And that's kind of what we're going to be talking about for the rest of the week. Okay, does everybody see that? What if I just make up another problem and say 3 times 4, which is 12. Raise your hand and tell me which numbers out of this problem right here are factors. Factors. Preston?
3 and 4.
3 and 4. Does everybody see that? Okay, so the numbers that are multiplied together in order to get this product are considered factors. Okay? All right, we talked about prime. What was the other word that we talked about the other day? What's the other word that we talked about the other day, Madison? Composite, right? Composite number. So everybody as a whole, let's do the definition, okay? A composite number is a whole number greater than 1 with more than 2 factors, right? So what's an example of a composite number? Hayden? 9, okay? Or wait, yeah, that's exactly what we were talking about, okay? So let's look at it like this. So Hayden says that 9 is a composite number. Raise your hand if you agree. Raise your hand if you disagree. Okay, well let's see why. Let's go ahead and make another T-chart because this is what we talk about in our brain work. Okay, what are factors? We know what factors are now, kind of, right? A little bit. Maybe not completely, but we kind of know what they are. What are, starting with 1, what are the factors of 9? Okay, Josie, you tell me. 1 and 9, okay? Is that it? No, because if it was it, then what would this number be? Prime, okay? Sky, what are some other ones? Let's go. 9 times 9? Well, maybe not 9 times 9, because 9 times 9 would be what? 81, right? So think about it. Keep thinking. Peyton, can you help her out? 3 and 9? 3 and 9. Think about it. 3 times 9 would be what? 3 and 3, okay? So she says 3 and 3, because if it was in a multiplication problem, you would say 3 times 3 equals 9, right? And 3 is a factor, right? Okay. So that's what we're going to be talking about today, is touching a little bit on factors. But let's go ahead and look at the I can statements, okay? We've kind of already done this first one. And it says, I can identify a factor in a multiplication problem. Do you feel like you can do that?
Yes.
We just did it, right? But we'll be able to do it even more by the end of the lesson. All right, use counters to create an array. How many people know what an array is? Okay? We know what an array is, but we're going to create more today. Okay? The next one is solve a multiplication problem using counters. Did you know that you could probably solve a multiplication problem by using an array or using counters? Right? We'll do that too. And the last one is solve a multiplication problem by drawing arrays. I know that we've done that a little bit in our brain work, but we should be able to do that too by the end of the lesson, okay? All right, so I'm going to go ahead and read to you a book. Some of you may know it, some of you may not. But this is going to kind of put factors in your head a little bit differently, okay? So just listen up, and I'll try to make sure that I get all the pictures so that you can see them, okay? So 100 Hungry Ants is the name of the book. Okay? A whole hill of hungry ants, their faces all aglow, came swarming from the forest to cross the field below. A soft breeze fanned and the sunshine whisked them on their way, a hinting of yummies for their empty tummies. That meant picnic, hooray. See all the 100 ants? It's a long line, isn't it? Yeah. Okay? 100, make sure you pay attention to the numbers, okay? Just gotta be thinking about factors. 100 ants were singing and marching in a row. We're going to a picnic, a hey and a hidey-ho. Stop, said the littlest ant. We're moving way too slow. Some food will be long gone unless we hurry, so with 2 lines of 50, we'd get there soon, you know. All the ants raced here, there, up, down, and to and fro. There'll be lots of yummies for our hungry tummies, a hey and a hidey-ho. 100 ants were singing and marching in 2 rows. We're going to a picnic, a hey and a hidey-ho. Stop, yelled the littlest ant. We're moving way too slow. More food will be gone unless we hurry, so 4 lines of 25. We'd get there soon, you know. All the ants raced here, there, up, down, and to and fro. We hope to get the yummies for our rumbly tummies, a hey and a hidey-ho. One hundred ants were singing and marching in 4 rows. You kind of see how it's not as long anymore? We're going to a picnic, a hey and a hidey-ho. Stop, screamed the littlest ant. We're moving way too slow. Lots of food will be long gone unless we hurry, so 5 lines of 20. We'd get there soon, you know. All the ants raced here, there, up, down, and to and fro. There might be a yummy for a grumbly tummy, a hey and a hidey-ho. "100 ants were singing and marching in 5 rows. See? We're going to a picnic, a hey and a hidey-ho. Stop, shrieked the littlest ant. We're going way too slow. All the food will be long gone unless we hurry, so, what do you think? 6? No, they jumped to 10. With 10 rows of 10, we'd get there soon, you know. All the ants raced here, there, up, down, and to and fro. There better be yummies for our grumbly tummies, a hey and a hidey-ho. Who do you think's going to be in trouble if there's not? Right? 100 ants were singing and marching in 10 rows. At last, we're at the picnic, a hey and hidey-ho. The line's shorter, right? We'll see. Stop, yelled the littlest ant. We've traveled too slow. There's no food for us to eat. You took so long with Rose. You think it's his fault? We'll see. All the ants raced here, there, up, down, and to and fro. There aren't any yummies for our growling tummies, a hey and a hidey-ho. Oh no. See that? I wouldn't want to be the littlest ant. All right. 99 ants were swarming from each and every row in hot pursuit of one little ant who quickly turned to go. It's not all my fault, you know. That's all that's left. Just an empty plate. So it takes a long time. But raise your hand and tell me what you saw in that book that kind of relates to what we're talking about. Emily?
Well, first they started out with 100, and then that little ant said stop, and then they went to 2 rows, which had 50.
Right, okay. So Emily says they started with 100. Okay. So let's start with 100. And you said they made 2 rows, right? 2 rows of what?
50.
50. So 2 rows of 50 to equal that 100, right? So would this not be kind of like a multiplication problem? Yes, maybe? So which ones are the factors? What numbers are the factors? Okay.
50 and 2.
2 and 50, right? So 2 and 50 would be a factor of 100, right? What about the next one? Kind of think back to the story a little bit. Bella? It's okay if they're out of order. Just think back.
They did 10 rows.
They did 10 rows, right? So 10 rows of what? 10 rows of how many to equal 100? Kendra, you want to help her out? 10 rows of how many to equal 10, right?
Also, I have a different one.
Okay, hang on just a second. So we see that 10 is a factor, right? 10 and 10, but 10 and 10 are the factor pair, okay? All right. Let's see. Justin.
4 rows of 25.
4 rows of 25. Good one. Does that not equal 100 too? What do you think?
Yes.
Yes? So where's the factors there? Everybody? 4 and 25, right? Okay. What about another one, Anna?
5 rows of 20.
5 rows of 20. Right? And that still gives us how many?
100.
100, because the story talks about 100 hungry ants, right? Okay, so there again, 5 is a factor, and so is 20. Right? Okay. So what I would like for you to do, if you haven't already cleaned off your desk, what I'm going to do is I'm going to pass out counters. So everybody's going to get their own bag of counters. You should at least have 20 in here, but some of the bags may not, okay? That's no problem. Just raise your hand if you need more. But we're going to work some, we're going to make arrays, kind of like how the ants were in lines like that. Did you not think that maybe looking at the picture that the ants were in some type of array?
The last one was in the array.
The last one? Uh-huh.
They were all.
It looked most like an array?
They were all in.
They were all in arrays, right? All of them
Except
did.
the first one.
Yes. Well, except for the first one, that's right. So I'm going to pass these out. Okay. Like I said, there should be 20, but if not, it's okay. Don't worry about it until we get halfway through a problem and you don't have enough, and then I'll come by and give you some. Yes, you may go ahead and open them, put them out on your desk. You're welcome. Just go ahead and space them out on your desk. Now don't play with them or build houses or anything.
I don't think you can go much.
Can't?
I bet you can. Yeah.
Okay. Need one more? Don't worry about it. Class.
Yes.
I need all eyes on me. So what I'm about to do is I'm going to write a multiplication problem up on the board, and I want you to solve it by creating an array. Okay. So 3 times 4. Don't answer it. Just go ahead and create an array that shows 3 times 4.
Can we make it either way we want?
Just an array, guys. It doesn't matter which way. We'll worry about that a little bit. Okay. Just give me a thumbs up once you've created your array. I'll give everybody a few more minutes. I see some good ones. Okay, everybody good? Go ahead and put your thumbs down. Alright, so one way that you can create this array, because we'll get more picky about it a little bit in a little bit. You could have done it this way. Right?
Yes.
Yes? Because does that not show 4 times 3? And what is 4 times 3, guys? Everyone? 12, right? So can you also see that there's 12 counters? Right?
Mm-hmm.
So what other ways could I have done it? Jackson?
4 across and
4 across, which is simply just taking it and flipping it this way too. Does everybody see that?
Yes.
Okay, go ahead and clear them off and we'll do a few more. So go ahead and create that array. And give me a thumbs up once you've done it. Remember, we're working on 5 times 2. See some good ones. I'll give you about a minute to keep working if you haven't already. 5 times 2. Okay, so everybody tell me 5 times 2 is what? 10. So in your array, you should have a total of 10 counters. Okay? Ways that we could have done this might look a little different, but not really, they're the same thing. So, could have done it this way with 2 rows or 2 columns and then 5 in each column, right? Or it could have gone this way, right?
Yes.
But by looking at this, how I had this multiplication table set up, or how I had the problem set up, 5 times 2, which way do you think is probably correct? 5 times 2. Think about it. Take a few minutes to think about it. Wolfgang, what's the correct way? Would it be this way? Because we're starting with 5 times 2, or would this represent 5 times 2? This way? Why? Why would that be 5 times 2?
That's 2 times 5.
This one? You meant the other one? Okay. So, either way, it's still the same answer, right? Because does it matter which order you go in a multiplication problem? No, because
It's
5
still just
times
the
2
same
is still
answer.
the same thing as 2 times 5, right? And 5 and 2 are what of 10? What's the one thing that we were talking about? Factors, right? Good job. Let's do one more and then we'll move on. Times 3. So go ahead and create 6 times 3. Give me a thumbs up once you've finished. You need more? And some of you may need a little bit more, because I know that the counters are messed up. Does anybody need more counters? Has everybody created an array? Yes. Okay, go ahead and tell me, what is 6 times 3? 18. So you should have how many counters on your desk? 18. So by knowing that 18 is our product, what is 6 and 3? What were we talking about? They're factors, right? So here's your factors. Y'all are so smart. Okay, so let's go ahead and look at the ways that we could have done this. So 6 times 3, I could have done 1, 2, 3, 4, 5, 6. And I could have put how many in each? 3. How many? Everybody? 3, right? Because it's 6 times 3. And we said 6 times 3 is 18. Or you could have done it this way. Same thing. So did we not just create an array using counters? Yes?
Yes.
Did we just solve a math multiplication problem using counters? Yes. Okay. So we've done the first 3 already. So what I would like for you to do, you can go ahead and put your counters all together. I'm going to come around to each table. You are going to work with your table mates, okay? I'm giving you 5 index cards that have 5 different multiplication problems on them, okay? I know that you're not going to have enough counters on your own for some of them, so if you need to work with your table mates all together in order to form that array. Does that make sense? Yes. Okay. So once I give you your cards, you can go ahead and start working. You're going to work together, guys. And when you finish one, raise your hand so I can come by and check. Class. Yes. Okay, so now that I've given you your cards, I said you could go ahead and start working. When you're working on just one, you're working on it all together. Okay? You're working on just one all together. Everyone in your group raises their hand when they're ready. Micah, what do you do when everybody at your table is ready? Wolfgang, help her out. What do you do when everybody in your group is finished making that array? You raise your hand for me to come and what? Check, right? Okay.
Kendra, you can maybe use some of ours if that's something.
Your whole group does it.
Okay. I think I have enough.
You flip one card, everybody works that one card together.
8 times 7. 7 times 7 is 49. 56. Because 7 times 7 is 49. Times another 7. Plus 7. So we have 56.
I don't think I have enough for that. Yeah,
20, 60.
Everybody has different. They did too? Okay, so look. You created an array that has 2 times 7, right? Yes, because there's 2 and in each row there's how many?
It looks like the next one.
Seven.
It's getting a little difficult. I can't really understand.
So you have how many?
Okay, let me count.
That way. Alright, so move on to the next one.
Okay, we gotta fix that.
You ready?
Okay, I can
2 times 7, right? What is 2 times 7? 14, right? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And it's 2 rows of how many? 7 rows of 2. Right, so go ahead and move on to your next one. Alright, yeah. Not, ooh, y'all had a big one. Okay. So 9 times 6 is what? Let's see. 54. Okay, so do you think that there's 54? Yeah.
No.
No? Because you can tell by what?
The only I could just use it from the one that I just had, 2 times 14. I just used like air hockey. I didn't have to mess it all up. It's like air hockey.
1, 2, 3, 4, 5, 6, 7, 8, 9, right? And is that not the same as 9 times 6? To be 54. Right? Okay, good job. Move on to the next one.
So let's do
Remember, everyone in your group raises their hand when you're ready. Okay. All right, Pete, what did you do?
We did it.
What is it? 16. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And how do you, if you didn't count all of them, how did you know that there was 6 in there? There's 2 rows of. Good job. All right, go ahead and flip to the next one. 4 times 3. Okay, what is 4 times 3? 12. So you didn't want to count all of these, but if you did count all of them, you should have how many? 12 total. And then how many? You have 1, 2, 3, 4 with how many? 4 rows of 4 and 3 rows of 4. Good job. Move on to the next one. Y'all finish?
It's 7 times 6.
Ooh, 7 times 6. Y'all had a big one. So what is 7 times 6?
42.
42. So did you count those individually to find out that it's 42? So you know that there's 7, and in each row of 7 you have how many? 6. And that equals to? 42, right?
And we have leftovers.
Awesome. Keep working. Good job. Move over to your next one.
Actually, let's do different. Let's do
We didn't have enough chips, so we had to only make one array.
You only got Landon. Okay, it's Landon. Okay, let's do 5 on the top. They're back. Okay, in there, he's just I'm famous. It's 5 times 4. No. Garrett is a quarterback.
Okay, which one did you get this time?
9 times 2.
9 times 2? Okay, so what is 9 times times 2? 18. Did you count all those to figure that out?
2, 4, 6, 8.
If you didn't want to count all of them, how could you figure that out? You got how many rows? 2 rows of 9, or 9 rows of 2. And 9 times 2 is 18. Good job. Move on to the next one.
4 times
20. 5 times 4. Okay, what is 5 times 4? What is it? 5 times 4. 20, right? What are the ways you could have found that out by looking at your array? You could have counted all of them, right? Right. Or you could have looked to see that you have 4 rows. And how many in each row? 5. 5 rows. Yeah. Y'all done? Yeah. 5 times, or wait, okay. 8 times 3. Okay. What is 8 times 3? That's okay, that's the point. Okay. So 8 times 3 is what? Yeah, what's 8 times 3? What is it? 24, right? So did you count all of these to figure that out? You did? But what was another way? Yeah, because you know 3 times 8. So you have 3 rows, and how many in each row? Or you have 8 rows, and how many in each? 3. Okay, good job. Work on the next one.
Yes.
Make sure that you're sitting down. I know it gets a little bit exciting, and sometimes you have to stand up to see the arrays, but I need everybody in their groups, okay? Remember, everyone raises their hand to let me know that they're ready. So 2 times 4 is what? 8. Did you count all those to figure that out?
Yeah.
You did? No. Because you know you have 2 rows of how many? Or you have 4 rows of how many? 2, right? And 8 times 4 times 2 is 8. Good job. Good job. Okay. Make sure you're working on your arrays. Alright, so what is it? 8 times 5. How much, or what's the answer? 40. Did you count all those? So you have 5 rows, or you have 8 rows of 5, right? Or you could have had 8 rows of 5 rows of 8. Good job. You know that if you have 2 rows of 4 or 5 rows of which one did you get? 9 times 4.
We just have to do a little row.
That's okay. So 9 times 4 is what? 32. Count all those, figure that out. Right? But you could have done it by saying that you have 9 rows of how many? Or 4 rows of how many? Alright, on to the next one. 6 times 7, which is what? 42. Did you count all those to figure it out? You did? But what could you got? How many rows do you have? How many rows do you have? You can have 6 rows of, or you can have 7 rows of 6, right? Good job. Alright, move on to the next one. Finish? Alright, what's the here? Okay. 4 times 6 is what? 24, right? Did you count all those to figure it out? Okay. Jackson. So how many rows could you have had? 4 rows of how many? 4. You could have had 6 rows of 4. Good job. Alright. Okay. Class 5.
Yes.
Okay, how many people are still working? How many index cards do you have? If you have 1 index card left that y'all haven't worked out yet, raise your hand. If you have one index card that y'all have not worked out yet, raise your hand. If you have 2 index cards that you have not worked out, raise your hand. If you have 3 index cards that you haven't worked out, do you have 2 or 3? You have 3 cards y'all haven't worked out yet? You've only done 2? Okay. Alright, I'm gonna give them a few more minutes, okay? For those that are finished, if you could, go ahead and place your counters back in your bag for me. Stack up your index cards, okay? And I'm gonna write some, you're gonna get out your whiteboard that should be inside your desk, and I'm gonna write a couple of problems on the board, and you're gonna work on drawing those.
Arrays?
You're gonna write, yes, you're gonna solve it by using arrays.
Today's like all arrays.
Yes.
Yeah.
You have 5 rows.
Yes, that's how
Or 5 rows.
Now, I think we are this egg. We'll take with our next one. She's okay. Toast.